Hi everyone. Today we want to learn detect the flood and flood mapping with the Sentinel-1 radar satellite. And Sentinel-1 is a radar imaging satellite mission under the Copernicus program of the European Space Agency (ESA), and it consists of a twin satellite Sentinel-1A and Sentinel-1B equipped with a synthetic aperture radar cell sensor operating in the C-band and capable of capturing Earth's surface regardless of a cloud cover or time of a day. Why use the radar SAR for flood mapping? Unlike the optical sensor, like the Landsat Sentinel-2 MODIS, you can watch the flood mapping with this sensor in our channel. The radar sensor actively emit a microwave signal and measure the return signal from the Earth's surface. And SAR is especially useful in the flood mapping because it can penetrate clouds and darkness and making it ideal during the flood period. And smooth water bodies scatter radar signal away, appearing the dark in the SAR image, and urban rural areas, vegetation and infrastructure backscatter more strongly, appearing the bright. And we have a two polarization in a Sentinel-1 VV and VH. We use a VV vertical transmit vertical receive polarization, which is sensitive to surface roughness and useful for distinguishing between open water and land. Mm, In the coding part, we can define the area of an interest. We choose the point near the Bangladesh. If we run this, we can zoom this area. And after this, we select the collection of a Sentinel-1 image. You can investigate more of this product from the Earth Engine data catalog available from 2014 until now with a 6-day revisit time. And you can see the bonds and units, mean and max and description. You can, yeah, more explore the user guides. And we selected the descending orbit and interferometric wide swath mode or IW. And we filtered this one with the AIU, with instrument and VV polarization and descending. And after this, yeah, we can need to define the time period. We define the 7th of August 2023. This is a reference day. We want to, the flood day, we want to map the pre-flood and after flood. We define the before of this period with a reference day and after the image like this. And we detect the water body with a backscatter threshold of minus 12 dB is used to separate open water low backscatter from land. And after this, we can use this threshold method to uh, find the water areas before and after. We can use some speckle noise reduction. This is optional, and SAR image have a speckle noise, and we smooth the water mask using the 1 pixel relation to reduce the small holes in the flood detection. And after this, we can define the variable for detect of a flood, flooded areas, dividing the water after, water before, highlight this change. This is a binary layer. And in the final layer, we add the map, the before image VV, after image VV, and we define the palette blue for before, green for after, and red for flooded areas. And if we run this code, yeah, we have not a visualization parameter. Yeah, we need to define a visualization parameter. for this one. Yep, we can add like this to one code. I define the -25 to maximum 0 with the black and white. And we have here 5 layer. I can turn it off all. This is a before VV, and this is after. You can see we have a more flood areas, and this is the water before, and this is the water after, and this is the difference of water before and after. If we turn down this, we can better compression, and you can play the threshold value for defining it and increasing the accuracy of this. The application of this method is real-time flood monitoring, disaster response and risk mapping, agriculture damage assessment, and urban flood analysis. Please like and subscribe channel, and thank you for your watching.